So now let's have a look on one more example. Prove that del cube u by del x del y del x is equal to del cube u by del y del x square if u is given by this function. So u is given and u is a function of x and y, two variable. Here m and n are constant, and you have to differentiate this u how many times? Maximum times, 3 time differentiation. But in which order? So as I told in just previous slide, uh, if this form is given, then you have to go in this direction. That means first you differentiate given function with respect to x. Whichever answer, that answer is differentiated with respect to y, and again that answer is differentiated with respect to x. That means 3 time differentiation successively, one by one. Okay, but in this order only. And when we want to find this, at that time again in this direction. So first we differentiate u 2 times with respect to x, and that answer will be differentiated with respect to y. And whenever we differentiate, you have to keep one thing in your mind. Then when we differentiate with respect to x, treat y as a constant, and when we differentiate with respect to y, treat x as a constant. This logic you have to keep in your mind. Okay, chalo. So let's start with the solution. First write down u which is given. First we want to find, one second, this term. So for that we differentiate with respect to x. So del u by del x, now differentiating with respect to x, so y raised to n constant, and differentiation of x raised to m is mx raised to m minus 1. We know the formula. Okay, now differentiate this term with respect to y. So what is the notation? Yes, del square u by del y del x on the left side in this form. So with respect to y na, so this term is constant, and differentiation of y raised to n is n into y raised to n minus 1. Now again differentiate this term with respect to third time derivative with respect to x. So with respect to x, that means this term, this bracket, this whole round bracket, this as it is, m as it is, and you have to just differentiate only this term, x raised to m minus 1. So we have m constant, this n into this is also constant, and differentiation of this x raised to m minus 1 is m minus 1 into x raised to m minus 2. Say this equation number 1. Similar way, before giving this, we are just rearrange this term. So m, n, and this m minus 1, all these three constant we are taking together. Then we will write down term x, and then we will write down term y. Say equation number 1. Same way we will find this, that is 2 times with respect to x, and then 1 time with respect to y. So let's start. First, always we will write down the u because we are changing the slide, that's why. And now we want to find this term. That means del cube u by, what is it, sir? 1 second. Okay. Del cube u by, so del u by del x with respect to x. That means m x raised to m minus 1 and y raised to n constant. Now again differentiate with respect to x, we will get del square u by del x square. That time m is constant. Okay, this m is constant, and y raised to n itself constant. So differentiation of x raised to m minus 1 is m minus 1 into x raised to m minus 2. Now again differentiating this term with respect to y. At that time x will be constant. So this whole term is constant, and differentiation of y raised to n, we know that n into y raised to n minus 1. By simplifying, that means taking constant together and arranging in sequence, we will get equation number 2. And from equation number 1 and equation number 2, you can observe that 1 and 2, you can observe that the left hand side is equal to right hand side. Okay, so whatever the order, just you have to keep one thing in mind, 2 time with respect to x, that means 2 time with respect to x on right side, 1 time with respect to y on left side, 1 time with respect to right on right side, with respect to y on right side. That means total number of derivative with respect to one variable equal, but orders are different. Okay, that is not possible that you are differentiating 3 times, but once you want to differentiate with respect to y 2 time and x 1 time and again 3 time, but in this 1 time y and 2 time x, these are not equal. For that you have to keep one thing in your mind, that if you are differentiate 2 time with respect to x, so on the left side also you have to differentiate 2 time, whatever the order may be different, but you have to differentiate 2 times, then 1 time y, then 1 time y, whatever the order. Okay, doesn't matter, but number of order, well, number of derivative with respect to y is 1, then on left side also it must be 1. Okay, then only then this mixed derivative theorem is verified, otherwise mixed derivative theorem is not verified. So now let's understand one more example. This is a tricky example, so let's have a more pay attention. We have u is equal to y plus x upon y minus z. So u is a function and we have this function of variable x, y and z, three variable. Okay, and we have to show that left hand side this is equal to right hand side. That means we have to find four derivatives, four different derivatives, 1 2 3 and this 4. So one by one we will find, and by adding this left hand side we will get right hand side. Let's have a look on the example solution. So let's start with the u which is given. First we will find this del square u by del x del y. That means in this form first we will differentiate with respect to y. Yes, let's have a look on the derivative. Now we want to differentiate with respect to y, and y appear on numerator and denominator both. So we have to apply quotient rule, and we know the quotient rule. In denominator square, in numerator denominator as it is, and differentiation of numerator minus numerator as it is, and differentiation of denominator. And by simplifying, by opening the bracket, we have this. By cancelling y, we will get final del u by del y is equal to minus z minus x upon y minus z whole square. This is only del u by del y. Now again differentiate, second time differentiation with respect to x of this term, only this term. So del square u by del x del y is equal to, we want to differentiate with respect to x, and in denominator there is no x, so denominator constant as it is. No need to apply quotient rule because we want to differentiate with respect to x, and in denominator there is no x, so constant, denominator constant. And differentiation of numerator, so differentiation of z is 0 and differentiation of x is 1, so minus 1. This is our equation number 1. Similar way we find del square u by del z del y. At that time first we will find with respect to z. Whatever the answer, we differentiate that answer with respect to y again. So when we differentiate with respect to z, so now take a look on the u. In numerator there is no z, only in denominator, and I told whenever your variable is in only denominator you can apply that something wala rule. That means differentiation of something 1 upon something is equal to minus 1 upon something whole square into differentiation of something. Okay, so we applied that formula only. So numerator y plus z as it is, and remaining part 1 upon y minus z, differentiation of this with respect to z is minus 1 upon something whole square into differentiation of something with respect to z. So with respect to z, so y 0 and z 1, so minus 1. Now this minus minus cancel out, so we have del u by del z is equal to y plus x upon y minus z whole square. Now differentiate this del u by del z with respect to y. So first again we will only write down del u by del z from the previous slide, and now differentiate this with respect to y. So y appear in numerator and denominator, so we'll apply division rule, that means quotient rule, and we all know what is the quotient rule, so no need to explain again and again that rule. You have, for that you have to practice that first order partial derivative from part 2 lecture. Okay, and now by simplifying this, y minus z we can take common, so y minus z common, so remaining y minus z only, and here y plus z in y plus x into 2, and we can cancel this term and it is cancel with 4, so we have y minus z whole cube, and by expanding this bracket and by simplifying this bracket we will get minus 2x minus 2y plus y minus y and minus z upon denominator as it is. This is equation number 2. Now write down u, and we want to find third one, del square u by del z square, that means 2 times with respect to z partially. Okay, so same rule, because z is appear only in denominator, so 1 upon something wala rule, and we know the derivative of u with respect to z already we have just find just previously, so we just write down and again differentiate with respect to z, again we will apply same rule, 1 upon something, so y plus z as it is, you can see, and we are remaining 1 upon y minus z whole square, 1 upon something, so 1 upon something, that means minus 1 upon something whole square, that means 4 power, and derivative of something is 2 y minus z raised to 1 and differentiation of that y minus z is minus 1 with respect to z, that's why. So we can cancel this minus minus and we can cancel y minus z with this power, so 3 power, so remaining term 2 into y plus x upon y minus z whole cube. This is our third one. Now last fourth one, that means right hand side. What we want to find, the u is given and we want to find del square z by del x square 2 times with respect to x, and it is clearly seen in denominator there is no x, so denominator constant, and derivative of numerator with respect to x will be 1 because differentiation of y is 0, y is constant, that's why. So 1 upon y minus z, again differentiate this with respect to x, there is no x in this term, so derivative of constant is 0. This is our equation number 4. Now we will put all the values from equation 1, 2, 3 in left side and we will get right hand side. That means answer will be 0 of left hand side. So write down left hand side, put the value of all these from equation number 1, 2 and 3. Here y minus z whole square, y minus z whole cube and y minus z whole cube. So we take LCM y minus z whole cube. So we have to multiply y minus z in this numerator here into minus 1. So we have this, and by simplifying, by cancel out term, so by simplifying, first we'll simplify, so minus y plus z minus 2x minus y minus z plus 2x plus 2y. By cancel out minus 2x plus 2x minus y minus 2y plus 2y and plus z minus z. So numerator is 0 upon something, 0 upon something is 0, which is our del square u by del x square and which is our right hand side. Okay, so how we can solve this kind of example we have seen. So let's have a look on one more example, and this is quite tricky question, so just pay more attention than previous example. Okay, so let's start with the solution of this question, and question is theta is equal to this and prove that this left hand side is equal to right hand side. So how we'll start this question? So here theta is a function and t and r two variable. So theta is a function of two variable r and t. Okay, so we differentiate theta first with respect to r because we want to find this del theta by del r. Okay, so let's start with the solution. One by one we will apply this left hand side and then we will find right hand side and we will check both the answer are same or not. Okay, so let's start with the del theta by del r. So here theta, which is given in the question, when I differentiate with respect to r, t become constant, so t raised to minus 3 by 2 constant as it is, and differentiation of e raised to is e raised to, and differentiation of this power by chain rule is 4t constant minus constant, and r differentiation of r square is 2r. By cancel out this, and we can write this term as theta. You can see clearly in the question. Okay, why I'm writing instead of this theta? Because this large term, if we'll take for the next derivative, it will be clustered, it will be very complicated. That's why I'm writing theta in the place of this, and this minus r by 2t. Now just multiply r square to this answer. So we multiply r square on the both the side, so r square, r square. By simplifying this, r square r become r cube minus, we will take outside a theta and 2t as it is. Now we differentiate this whole term with respect to r. That means we differentiate this with respect to r. At that time, theta and r cube both are our variable, because theta is a function of r and t. So theta contains r, so theta is our function and r is our variable, but 2t is constant. So minus outside, and we will apply product rule here in between these two terms, this and theta. So first theta as it is, differentiation of this term to t constant, and differentiation of r cube with respect to r is 3r square, 3r square, plus second term as it is, matlab this term r cube into 2 divided by 2t as it is, and differentiation of theta with respect to r is del theta by del r, because theta is our function, that is dependent variable. Now we will put the value of del theta by del r, because we know the value. Where is the value? This is here, we will put here. Okay, so we have minus as it is, theta as it is, this term as it is, r square r cube by 2t as it is, and value of del theta by del r is theta into minus r by 2t, this one. Okay, now we have this answer, and now just we have to multiply 1 by r square. Before that we just simplify this, so this term as it is, this minus, that means this minus multiply with this both term, so minus plus minus, and minus minus plus, and plus plus plus. Theta as it is, 2t in denominator becomes 4t square, and r cube into r becomes r raised to 4. Now we multiply only 1 by r square on both sides, so we have only, first we will write down the term this, and multiply 1 by r square, this 1 by r square. So if we take 1 by r square inside this term, this both term, so r square cancel with here and cancel with here, so here only square. So this is our final answer of left hand side. Same way, we have theta is given, and in right side we want to find only with respect to t partially. At that time r is constant. Okay, so t is appear here and here, both in both term. So we will apply product rule here, and what is product rule we know. So first t raised to minus 3 by 2 as it is, and differentiation of e raised to something is e raised to, and differentiation of power by chain rule here, so this minus as it is, and r square constant as it is, and differentiation of this 4 is also as it is, and differentiation of 1 by t is minus 1 by t square as we know, plus now this e raised to term is as it is this time, and differentiation of t raised to minus 3 by 2 is minus 3 by 2 forward, and 1 power minus, and minus 5 by 2 t raised to. Okay, now we can write this term as a theta as just previous, because we want to answer in form of theta, that's why. So this is theta, minus minus cancel out, r square by 4t square, that means first term we will get. Now this minus comes with this plus, so plus minus minus 3 by 2 here, e raised to as it is, and t raised to minus 5 by 2 will be written as t raised to minus 3 by 2 into t raised to minus 1. You can see if base is same, and in between multiplication and addition of power, minus 3 by 2 minus 1 is minus 5 by 2. Why I am just writing this? Because this t raised to minus 3 by 2 and this e raised to combined will be theta, and t raised to minus 1, that means 1 by t. Okay, so we have this term 3 by 2 as it is, this 1 by t as it is, and this is theta. This is our equation number 2, and it is clearly seen that from equation number 1 and 2 these both are same. See, theta into r square by 4t square with plus sign, this is here, and minus theta into 3 by 2t is with minus sign, this is here. So both are same. You can write minus a plus b or b minus a, both are same. So left hand side is equal to right hand side. One more example we have, that if u is given, then find, then show that del cube u by del x del y del z, that means 3 times derivative of u with respect to, in which order? From right to left. That means first we differentiate with respect to z, then y, then x. We will get this answer. How? Let's have a look. U is given, differentiating with respect to z, so e raised to, and differentiation of this power is 3xy. Now again second time differentiating with respect to y, so differentiation of e is e, differentiation of this is 3x constant, and differentiation of y is 1. Now second term as it is, and differentiation of e raised to is e raised to, and power, differentiation of power with respect to y is 3xz, because differentiation of y is 1. Now we can take common what? E raised to 3xy. So in second bracket we have 3x, and multiply this two term 9x square y z. Now again differentiate this term with respect to x, which is our last final. So third time derivative del cube. So again use product rule in between these two terms. So first as it is, differentiation of second with respect to x, plus the second term as it is, and differentiation of first term with respect to x. With respect to x, that means y and z constant. Okay, so this as it is, and differentiation of power is 3yz. Now take common e raised to 3xyz. So we have our final answer. Okay, so now these are the sum which you have to solve by yourself. These are the DIY, do it yourself. You practice this example, then next lecture will be more easier for you. Okay, so don't forget to practice. Okay, so thank you for watching this video. We will see next lecture with next topic. Thank you.